Okay, so, ladies, today what we're going to do is we're going to formalize some rules. In other words, create what's called an algorithm. Have you heard that word before? Algorithm? An algorithm is simply a method. Okay? And you're going to hear that word a lot in mathematics, an algorithm. We have an algorithm for adding, right? You line up the numbers, and then you add straight down the place value columns, right? We have an algorithm for multiplying. We have algorithms for everything in mathematics. So we're going to talk about the algorithm for multiplying fractions. And most of you have seen it before because we probably did a little bit of it in class in this very room, right? But today what we're going to do is really formalize it and get you the formal steps, the process you want to follow. Because everything we've done so far has been kind of touchy-feely, looking at the pictures and stuff, right? So this time we're going to get a formal process. And this is the process that's going to lead you on to being able to do very small fractions or very big fractions, fractions in algebra later. Okay? So this is the thing that you need to make sure you understand. Also, when we're talking about multiplying with fractions, okay, I know where you're going, right? Because I know what you're going to have to do with fractions from now until university. So I'm going to show you a process that might be slightly different than what you're used to. But trust me that when I tell you that it will make your life easier if you do things properly now and not have to make corrections later. Does that make sense? Right? If you do it right now, then you don't have to correct it later. Because when you correct it later, when you're learning new things, it makes it very, very difficult. Okay? So here is our process. And there's nothing here that you haven't seen. Hey, good morning. How are you? All right, so here is our process. Here's what we're going to go through our work to get to where we need to be, okay? The first thing you're going to do is simplify. And I know that that's not multiplying, right? And we're talking about multiplying fractions, but before you multiply, you're going to simplify. And the beauty of that is it rhymes, so it's easy to remember. Before you multiply, simplify. Right? And now, many times you're taught to just multiply and not worry about this step. But what happens is the numbers get really big, and then you have to simplify really big numbers. Are we better at working with 2s and 4s or 80s and 95s? You betcha. So it's better if we're working with smaller numbers. So this keeps the numbers smaller. And then later, when we move into algebraic fractions, if you don't simplify first, then you cannot make it work. It can't work. So, would you rather take a little time now to learn a method that will work always, or learn something that's easy now and then try to fix it later when the problems get really hard? Okay. Let's learn it now while it's easy. Okay? So, yes, this is not the way that Education Perfect does it, and it's not the way you've probably seen it in the past. But, right, you're out of junior school now, aren't you? So now we're moving on and moving forward and building up to moving up to new things, right? So keep that in mind. So, is this the way every teacher teaches it? No. Is this the way you're going to see it in Education Perfect? No. But, is this the way you need to see it so that you can move forward? Yes. Okay? So trust me. Does that sound good enough? All right, you trust me. Okay, so here we go. Now simplify. We've done that before. That simply means that we look at the numerator, which is which number?
The
top number, and the denominator, which is the bottom number. And we see, is there any number that will divide evenly into them? Right? Remember that? So say they both divide by 2, then we can divide that 2 out and make the fraction smaller. Okay? So I'm going to, sorry, I should have divided it in half. So let's just talk about simplifying. So say we had 8 over 10. Would you leave the fraction as 8 over 10? No, because both 8 and 10 will both divide by what number? 2. So dividing them both by 2 gives you 4 over what? 5. Remember, we've done that before, and you must know how to do that. I guarantee it will be on your assessment. Okay?
This very question.
Okay? Well, maybe not this very question, but the very process. Okay? But when we're talking about multiplying, when we're going to simplify before we multiply, if you're multiplying, do you only have one fraction? It's not multiplication if you only have one thing, is it? You have to have at least what? 2, right? Which tells us that we're going to have not one denominator, but 2. Not one numerator, but 2. But because it's multiplication, it makes it very easy to still simplify these. So what we can do when we simplify before we multiply is divide out any common factors. It's been a while since we talked about that, but remember, factors mean things that divide evenly into each term. So here, 8 and 10 both had a common factor of 2, right? So we divided out any common factors. But because we're talking about multiplication, we're going to have more than one numerator and more than one denominator in both. Don't put both. In either numerator or denominator. So in other words, you're going to have more than one numerator or denominator. You don't care where it is, but it must be numerator to denominator. In other words, I can only divide if I'm crossing that fraction bar, because the fraction bar literally is a what? A division symbol, yeah. Right? But you have to be going from the top to the what? Bottom, right? Numerator to denominator. It's the only way that works. Okay? After we do that, then you're simply just going to do what you've used to do, is multiply straight across. We're going to do lots of examples of this. So it's numerator times numerator over denominator times denominator. And that gives us our answer. And as long as you've simplified it before, make sure you've simplified it completely before you do the multiplication, then you won't have to simplify it anymore. It will always be in its simplest form. Okay? So again, we're going to do lots of these because simplifying before you multiply is probably a little different than what you're used to. Some of you have probably seen it that way before, but some of you haven't. Okay? But I'm going to show you, and it's very easy. But again, this only simplify before you, what is it? Multiply. If it doesn't rhyme, you can't do it. Okay? So can I simplify before I add? Nope. Simplify before I subtract? Nope. Simplify before I divide? Nope. It's simplify before you what? Multiply. Okay? Remember that half the battle in mathematics is not doing the math. Can you add 2 and 5? Yeah. But half the battle in mathematics is knowing when to do what. Yeah? Okay? So, we're going to look at lots of examples. We're going to do several examples together. And then we're going to play our favorite little game.
Bingo.
Where I call on you. Yeah, it's pretty much bingo, isn't it? I'm going to call on you to answer questions. So that should tell you that if you're not paying attention right now, when we're doing these together, you're going to feel uncomfortable in a minute, right? I'm not going to give you difficult ones. So we're not going to worry about the math too much. And I'm going to walk you through just like I always do because I want to make sure that you're to model the behavior that I want to see, right? So I'm not going to give you any question that you cannot answer. But if you're not paying attention, you will not be able to answer these, right? So focus. That's our key today. And it's Monday, so that's easy, right? Everybody's all ready to go on a Monday.
No. Everybody's ready to tired from the weekend. Jesus, like,
Oh, no. See, the weekend you're supposed to rest and get ready for me.
Tuesday's today.
Tuesday's better? Oh, well. Well, we don't have Tuesday. Okay, here we go, guys.
Wednesday as well.
Are we ready? So, what we're going to do is I'm going to write some down. Now, do you think that everything will always simplify? No. So, but we always have to check first. Yes.
What if it's like a 15? Because like today in the education thing, there was a 15 years to simplify it, and you can't half that thing.
Yeah. Well, then don't worry about it. If you can't simplify it, then don't worry about it. Yeah. Okay. You betcha. Okay. Here we go. Let's see. So let's just look at some examples. Now these are examples, but of course I'm going to use the whole page because it shows, but they should be on the right side of your examples, right? Okay, next to your steps. So let's say we have 2 over 11 times 3 over 5. Now, I'm going to walk you through this one, and off to the side, I'm going to show you the way the series of questions should be. So this is the way I want you to think through when you see this problem. First, what operation is it? If you don't know what operation you're dealing with, then you won't know how to solve the problem. Does that make sense? Can I add when I'm supposed to multiply and get the right answer?
Do we write that?
Yes, please do. Okay? Could you add when you answer my question though? Can you add when you're supposed to multiply and get the right answer? No. So you have to know what operation. So who can tell me here what operation symbol we have up there? It's your favorite X. I didn't change it to a dot, even though I want to. Multiply. Exactly. We're multiplying. But is all multiplication the same? No. 2 times 3 is not the same as 2/3 times something, is it? Because remember that fractions aren't really numbers. Fractions, that fraction bar is really a what kind of symbol? Division. So they're not really numbers, so they don't behave like numbers. So we have to know what we're multiplying with. And in this case, we are multiplying what kinds of things? What are they called? Starts with an F. We've been working with it. You betcha. Multiplying fractions. Okay? What we're doing here is we're putting ourselves in the right mindset. We're not just jumping in and starting to look at stuff and do things. That's never a good idea. Stop. Think about it clearly, right? Is it a good idea just to run across the street as fast as you can?
Yes. No.
Without looking first? No. You stop. You assess the situation. Is it safe to cross the street? And then you go across the street when it's safe, right? Do you cross the street wherever you want to? No. Look a little guilty there. No, you don't, right? You don't cross the street wherever you want to. You go to the corner or go to a crosswalk, etc. Okay.
That means I'm cheap and they're not going to get hit by a car, so I just follow them.
Okay, well, be careful, sheep. All right, here we go. Come back to me. Come on. All right. So we're multiplying fractions, and we need to know that we're multiplying, and we need to know that they're fractions, because multiplying fractions has specific rules, doesn't it? The first step for multiplying is actually not to multiply, but to what? Simplify. And remember, we can simplify any numerator to any denominator. because it's multiplication, it doesn't matter where it comes from, but it has to be from the top to the what? Bottom. So, let me walk you through how that looks. Let's see if I can find a good color here. So the first numerator is a what? 2. Here's our first denominator is 11. Is there anything that'll divide evenly into 2 and 11 at the same time? No. What's our second denominator? 5. Is there anything that'll divide into 2 and 5 at the same time? No. Well, that tells me that the 2 doesn't have any common factors in the bottom, so we won't worry about it. What is our second numerator?
3.
And our denominators, again, are 11 and 5. Is there anything that'll divide into 11 and 3 at the same time? Be careful. No. Is there anything that'll divide into 3 and 5 at the same time? No. So, were we able to actually simplify anything this time? No. But were we required to look anyway, even though we didn't? Yes. Right? There may not be a car coming, but you still need to look. Right? Because being run over is not good. Okay. So, same thing here. Math is a lot like that. All right. So we couldn't simplify, but we looked at it, and we will simplify some, though. So there'll be some where you do. At first, we're not going to worry about it too much, but I still want you to walk through the questions, because you still have to look for those cars, even though it doesn't look like there's one, right? All right. Then, okay, Taylor. First things first. In order to be able to work any problem, I first have to know what? What we need to do with it, otherwise what is known as what operation, right? What operation, okay? Yes, did you get a question? Or do you... Cora?
Yes.
And in this case, what operation do I have?
Multiplication.
Multiplication, excellent, good job. Sally, but am I multiplying with 2s and 3s? No, these are what kind of things? Well, these are fractions. There you go. They're fractions, right? And I need to know that because multiplying with fractions have different rules than multiplying with just plain numbers, don't they? Amelia. Amelia? Okay, all right, Amelia. So if I'm multiplying fractions, before I multiply, I must first simplify. There you go. Good. Simplify. Remember, it rhymes. Loading. And I can simplify any numerator to any what? Denominator. Any numerator to any denominator. Guys, you got it written right in front of you, so keep up. Keep it going. All right. Diksha. So let's start with the first numerator. My first numerator is a 1, and I never have to worry about that. Why? If you divide 1 by anything, yeah, who cares, right? So don't have to worry about that. So Diksha will make you go do the 3. So we've got the other second numerator is a 3. My denominators are 2 and 5. Do 3 and 2 have anything in common? Nope. Do 3 and 5 have anything in common? Nope. Okay. So was I able to actually simplify anything then? Nope. Okay. Eva. So then what do I need to do? Multiply how? Straight across. There you go. Okay. So let's do that. And we'll start with Quill. Quill. 1 times 3 gives me?
3.
3. Good. And we might as well finish it off. Quill. 2 times 5 gives me?
10.
And 3 over 10 is my completed answer. And I know it won't simplify. Why?
Because none of them want to be simplified.
Yeah, I simplified before I started, right? If it won't simplify in the beginning, is it going to simplify later? No. Okay? Good deal. All right. Let's look at another one. Are we ready?
Yes.
Okay. Let's find a good one. Here's a good one. 4 over 7 times 21 over 16. Go.
Oh shoot, we're doing actual work? Yeah. Wow.
One where there's actual work to do. Go. Here we go. Let me get a victim. I mean a volunteer. I mean something.
Volunteer.
Yeah. Let me volunteer someone. Sally. No, I get to volunteer someone. Sally. So, first and most important thing I can ever do for any problem is identify the what? What operation? You bet. You know what? You have to know what operation you're dealing with or you can't move forward. Yeah? Does everyone agree with that statement? Sally, what operation is this? Multiplication. Good deal. Diksha, I also have to know what kind of numbers I'm working with or what kind of things I'm working with. And in this case, I'm multiplying what kinds of things? Starts with an F. You know what they are. Fractions. There you go. Your notes are right in front of you, kids. All I'm doing is reading. You can read these. So, multiplying fractions. Good job. All right. Amelia. No, right? Amelia? Amelia, you're here. Hello, Amelia. Amelia. But when I'm multiplying fractions, before I multiply, what do I have to do first? It rhymes with multiply. Simplify. I've got to simplify. Good. Okay, got to simplify first. Renee, but since I have numerators and denominators and I'm multiplying, I can simplify any numerator to what? Any denominator, right? But I have to be going from top to bottom to simplify. Because, again, that's the fraction bar, isn't it? Saskia! There you are. Saskia, it's looking right at you this time, wasn't I? And so let's start doing that by looking at our first numerator. And our first numerator is a 4. And our first denominator is a 7. Is there anything that'll divide into 4 and 7 at the same time? No? You want to do the second one too? Okay. So here we got a 16. So 4 and 16. Is there anything that'll divide into 4 and 16 at the same time? They'll both divide by 4, won't they? Good. So let's do that division. Okay, Millie? So 4 divided by 4 will leave me a what? A 1. Anything divided by itself. Guys, shh. Here we go. And Millie, 16 divided by 4 leaves me with a what? 4. Right? Now, they were in different fractions. Did that matter? No. Okay, good. Eva. Hello, Eva. Now, the next numbers I have is a 21. And I have a 7 down here. Is there anything common to 21 and 7? Yeah, they'll both divide by 7, won't they? Right? Now, does it matter that the 21's on top? Nope. So 21 divided by 7, Eva, is 3. And 7 divided by itself, Eva, is 1. Okay? Now, Kenzie?
Hi.
Even though we've already done our 3 and our 4, we still have to look at it again to make sure that there's not something common. It's very rare, but occasionally, even after you do that, there's something common. But is there anything common to 3 and 4? No. But it can happen. All right? Okay, Taylor. So we're going to multiply how? Straight across. So 1 times 3 is 3. And in the bottom, 1 times 4 is 4. And is everybody happy with that?
Yes.
There you go. How easy is that? Pretty easy, right? But you've got to walk yourself through the process or you're in trouble. Okay?